This episode of Photonics Hot List is brought to you by Edmund Optics, where custom manufacturing is supported by a comprehensive range of measurement capabilities, including in-house laser damage threshold testing, custom-built industry-leading spectrophotometers, and aspheric stitching interferometry with less than 20 nanometers of uncertainty. Learn more at edmundoptics.com/manufacturing.
Hello, I'm Justine Murphy with Laser Focus World. Let's take a look at some of the amazing things happening in photonics. Real-time environmental monitoring and potentially even access to inaccessible locations could soon be possible with new nature-inspired technology. Researchers at Tampere University in Finland, together with a team from the University of Pittsburgh, have developed a tiny light-controlled robot that mimics maple tree seeds, also called samara wings, which fall to the ground by gliding in the wind. The artificial maple seeds gliding movements can be controlled with visible and UV light, while additive constructs that form a rotating glider allow the researchers to optically tune its terminal velocity, rotational rates, and circling positions. The technology's aerodynamic properties can be controlled via an azobenzene-based light-deformable liquid crystal elastomer the team also developed. The nature-inspired robot is ideal for environmental monitoring, the researchers say, and potentially as a means for delivering things like small samples of soil to inaccessible areas, including deserts or mountains. The team is now looking to equip the technology with GPS or other sensors for use in search and rescue operations and infrastructure monitoring. Showing promise for applications ranging from microscopy to quantum communications, a new approach to fixing light distortions is putting nonlinear optics to the test. A team from the University of Witwatersrand in South Africa can now send pattern light through obstructions without measurements, and most notably without distorting the message. With conventional processes, patterns of light can be easily distorted by environmental interferences. The researchers have overcome that issue using adaptive optics, a technique in which a mirror is precisely deformed to compensate for light distortion, but without the measurement step that's typically required. In their work, the team paired a structured light beam containing coded information with one that was unstructured to send it through an interference-riddled environment. This process used difference frequency generation, which involves sending two input beams through nonlinear crystal to create one output beam that shares the properties of those input beams. Essentially, the distortion in one beam cancels out the other, the researchers say, ultimately removing distortion altogether. Creating quantum memory and storing data that's sent via lasers as ultrasonic vibrations could be just a drumbeat away. Using optomechanical systems, researchers at the Niels Bohr Institute's Center for Hybrid Quantum Networks at the University of Copenhagen in Denmark have set their sights on advancing quantum systems and communications by developing a tiny quantum memory drum to replace platforms like atomic ensembles and rare earth ion-doped crystals. The team's quantum memory drum features a high-finesse optical cavity, as well as an embedded dielectric membrane that's just a few hundred atomic layers thick. When this drum is hit with a laser, the data-charged light signal becomes part of the drum's vibrations, which the researchers control using phononic crystal, a metamaterial with acoustic characteristics. Another component of the team's optomechanical setup are membrane resonators, modified versions of ones they previously developed, which tout long lifetimes and the ability to convert traveling optical signals into stationary mechanical ones. The researchers are now working to increase the bandwidth of their setup's mechanical memory. And that's your Photonics Hot List. Be sure to like and share, subscribe to our YouTube channel, follow us on social media, and visit laserfocusworld.com for the latest and coolest news and information. And check out our Following the Photons podcast too, to hear some really interesting interviews with the industry's top players. Until next time.